This is a story about electricity. Not the whole story, but what David Greger learned when he tried out his new plastic flashlight. Just then, his sister Marilyn came to his room, wondering why her comb was giving her so much trouble. It seemed to stick to her hair, picking up the ends. What David heard reminded him of a sound he had often heard during summer thunderstorms. And it reminded him of how when he scuffed his feet on the rug and then touched metal, a spark jumped. These are all examples of what we call static electricity. Marilyn tried to wipe off her comb, but look, it picked up tiny pieces of paper. But static electricity doesn't last long enough to do any work. To light a bulb, we must have a flow of current electricity. Anyone can make current electricity in a chemical cell, say out of zinc and copper. When these metals are placed in water and soda, we have one form of wet cell. With an electric voltmeter, David showed her the electricity that is made. It's the same kind of electricity that's made in a flashlight cell. This is what you might call electricity in a package. This flashlight dry cell has a higher voltage than David's little copper zinc cell. It has enough to light a tiny one-cell flashlight bulb. And that's how a flashlight works. The electricity flows in a circuit or path from the batteries, through the bulb, through this metal strip inside, and back through the batteries. But electricity flows only when the circuit is complete. Marilyn wanted to know how they make electricity for the house. David said he thought it was made with magnets. And by now, they both had many questions about electricity. And so the next Saturday, they took their questions to the local power station. Electricity is the movement of electrons. Now, this was the first thing they learned from Mr. Gibbons, the engineer at the power station. But now, what is an electron? A tiny negative particle, Mr. Gibbons explained. An electron is so tiny that a piece of wire only 1 inch long can hold more electrons than there are drops of water in all the oceans of the earth. Think of that. Now, when David scuffed his feet across the rug, he actually scraped electrons off the rug onto his shoes. He became charged with electricity. Of course, you can't see electrons, not on your shoes, nor even through a microscope. They're the tiniest things we know about. These electrons will jump off the first chance they get, as when David touched the radiator. David figured that Marilyn's comb must have scraped electrons from her hair and from her skirt. But why did the comb pick up the bits of paper? Mr. Gibbons told them that these electrons, or negative particles, are always trying to get together with positive particles. Now, we usually say it this way: unlike particles attract each other. So, when the comb got to be negative, it attracted the positive paper. Now, David recalled hearing that like particles push each other away or repel each other. Marilyn wanted to know what all this had to do with the wet cell that David made with the strips of copper and zinc. So Mr. Gibbons explained. The chemical action of the soda water causes the copper to give off electrons. These replace electrons which are attracted to the zinc. Then, said David, if there's a complete path, the electrons flow through the wire and through the meter and back to the copper. And if the circuit is broken, the electrons pile up there. They repel the other electrons behind, and the flow stops. Yes, David caught on quickly concerning the movement of electrons, and why circuits must be complete for current to flow. Now Mr. Gibbons asked whether they knew the difference between a conductor and an insulator. Marilyn said that copper wire is a conductor. It will carry electricity, but glass will not. How can we test what materials are conductors? We use a battery, a meter, and 2 wires in a tester, like this. The needle swings if the material conducts electricity and stands still if it does not. The plastic handle is an insulator. David was thinking about making a tester at home when the magnet reminded him, is the electricity in their home really made with magnets? Well, a long time ago, people found out that a magnet makes iron filings move into a pattern. Like this. This shows that around the magnet there are lines of force. And then, about 100 years ago, a man named Faraday discovered that a wire passed across these lines of force generated a small amount of electricity. In other words, electricity can come from magnetism. Not long after, another scientist discovered an effect when electricity is passed through a wire. This produces the same sort of lines of force as a magnet does, proving further connection that magnetism can be made with electricity. A coil of many turns of wire makes many magnetic lines of force, and a soft iron core in the loop makes the magnetism even stronger. In fact, the soft iron core becomes an electromagnet as long as the current flows. If it stops for a moment, the electromagnet drops the filings. When the electromagnet's lines of force are cut by a coil of wire, a much stronger current is generated. Then Mr. Gibbons brought out a small magnetogenerator, and it was fun to see electricity actually being generated. David looked at the magnets and at the coil of wire which passes through the lines of force when turned. Now this is the principle of the generators that supply the city with electricity. In the powerhouse, the enclosed generators are turned by steam turbines. In some parts of the country, great dams hold back huge quantities of water and release it to turn water turbines which drive the generators. From generating stations, current is sent out to factories, offices, stores, and homes. This electricity, as we have seen, is related to the static electricity the comb made in Marilyn's hair, and to the current electricity made in David's copper zinc cell. Tremendous amounts of electricity for our everyday uses are made by passing wires through magnetic lines of force, as in the powerhouse where Mr. Gibbons has been so helpful. At home, they both continued with their new adventure in electricity. David started building a tester to find out more about many conductors and insulators. Marilyn began making a scrapbook, planning to put in pictures showing how we use electricity in our homes. Of course, this was only a beginning, because with electricity being used for more things every day, there's always something new and fascinating to learn about it. For instance, you might find it interesting to learn how many different ways electricity has been used in making this motion picture.